to make a standard curve using the absorbance values we got from the Bradford assay and our standard protein concentration that we used. So from here, what I'll do is I'll click this data, which is not data that anyone from the labs had gotten. It's just sample data that I have. So I'll go to Insert, go to Scatter Plot, make a scatter plot. From my plot, I'll just get rid of my title, my grid lines, because I do not need them. And then that way you can kind of see your scatter plot dots and see how linearized they are. And they're pretty linear. Could be more linear, but it's okay. So from this, we will get the linear equation and the R squared. And the R squared just tells you how linearized your data points are. And that is important because in this specific assay, the protein concentrations are used to create a linear equation that you will use to find a sample's protein concentration that you do not know. So you want it to be pretty linearized, or otherwise you'll have the wrong protein concentration. So you'll click on the data points, right click on them, add a trend line, click on display equation on chart, display R squared. So I have my equation here. So I have y equals 0.7017x plus 0.0433. And then my R squared is 0.9892. The closer it is to 1, the more linearized your points are. And that's what you're kind of looking for. The further away it is from 1, kind of tells you that your points are not as linearized as they should be, and there's probably some sort of pipetting error or some other sort of error that caused the concentrations not to increase at a standard increment. So to find your protein concentration from your samples, what you will do is you'll take your linear equation and then you will try to solve for the protein concentration. So the absorbance that we got from the Bradford assay will be your y value, and the protein concentration, the x. So for the milk and high protein, we have our absorbance, and we will use our linear equation to find the calculated protein concentration. The expected here is just what we know is the protein concentration from the milk and the high protein, and we can just use that to compare our calculated to what is expected. So to find the protein concentration, we'll use the linear equation to solve for x. So I have y equals mx plus b. If I solve for x, I have x equals y minus b divided by m. So my b value is going to be 0.0433, like I said, and my m is going to be 0.7017. So I'll take my absorbance, and here in Excel you just hit equals to create an equation, parentheses, our absorbance for milk subtracted by RB, close your parentheses, and then divide that by your slope. This is the number we have. However, when we were making our milk and our high protein concentration, or concentrations that we used, we diluted them. So I will take this number now and multiply it by 50. So I'll add just another round of parentheses so that Excel knows to take that calculated value from the equation and multiply that by 50. And that should give me my protein concentration. The reason why we multiplied by 50 is because we made a dilution of the milk and the high protein in the PBS at first before we did the absorbance. So the absorbance that we have calculated is a dilution of the milk and the high protein. So then we'll do the same for the high protein. I will then click equals, and I'll just go ahead and do 2 parentheses for this one since I know I have to multiply it at the end by 50. So I'll have my first and my second. My second parentheses is going to include my absorbance subtracted by my B. I'll close that parentheses so that that value is then divided by my slope. I'll close parentheses again, so then that value will be what is multiplied by 50 in Excel. And then I have my protein concentration for the high protein. As you see, the milk is a lot higher than what was expected, as well as the high protein, and that's also because this R value, although it's 0.98, that's still not close enough to one where you're truly getting a linearized data plot that will give you the most accurate protein concentration for a sample. So from this, what I will do is I will finish editing this graph. I will get rid of the border. I will change the color of the data points, and then I will add axes titles. I'll put this onto Word. I need all of you to print this out for class because there are going to be questions on the quiz from this graph. I will not print out this graph for people who do not bring it, so you must print it out yourself and bring it to class. If you have questions about Bradford assays, how they're used, what the standard is, why the standard makes sense, why you use linear equation to find your sample's protein concentration, you can shoot me an email, or I can talk to you after class as well and further explain.